Okay, here we go with volume of prisms and cylinders. Some of you having trouble with the 3D interactive tool from SAS Curriculum Pathways. I found with using my MacBook as very difficult to use, but going over to my PC laptop I had no troubles at all actually. Goes to show you open source code doesn't necessarily work so well on the MacBook. Alright, the first thing we're going to look at then is the demo portion. At the top of the worksheet is just a review. You should be able to figure out the review part. Basically, we're going to look at the demo, understanding the formula for volume, basically. So I'm just going to show you the demo. I'm going to select the prisms and cylinders here. Anytime I'm moving too fast, you can just read the bottom, look up top, and it pause the video if I am moving too quickly. You notice that each solid is made up of a base. This is what they're talking about. And basically, the key to learning about volume is just understanding that the volume is based upon the base and how much of that base is kind of pushed up through the figure. So again, basically they're just saying the area of the base and then multiply by the height gets you how much is in the figure for volume. So now basically they're just showing you that each solid basically is made up of height, and basically it's the same formula as the area of the base, area of the base, area of the base times the height gives you the volume, and the base basically changes depending upon the figure. There they say the product of the volume of a right prism or right cylinder is equal to the product, the area, the base, and the height. So let big B, we call it now instead of little b for base, but big B represent the area of the base, and that area of the base can change depending upon what it is, a rectangle, a circle, or a triangle in these three cases. But it could be another figure as well, octagon, whatever. So there's the procedure: determine the shape of the base, calculate the area of the base, determine the height, and then multiply the area of that base times the height. Okay, we're going to look into composite figures. Basically, composite figures are the same exact thing, except for now we got to think about it in different parts rather than just in one underlying area. Here they're showing you that the base, the big B, is made up of a triangle, a rectangle, and a semicircle. And basically this leads us into like calculus ideas of trying to find the volume of a plastic chair, for instance, that a company would understand that, okay, we need this much plastic to make the chair, and then what tolerance do we have? Could we reduce that volume, or would the chair get too weak, or would the chair stay strong enough? Basically they simplified the area of the base, the big B, and now basically they just need to know the height. Once you find the area of that irregular shape, then we just multiply it by the height. And again, calculus just takes us to a different level in figuring out what if these shapes aren't regular shapes like triangles, squares, and and rectangles and semicircles. What if these shapes are way different? And that's what calculus can do for us. Okay, there's the demo complete area. If you flip over, hopefully you understand what the general formula for volume is. And now we're going to move into the practice area of the interactivity. So here basically we decide on, according to this table here, we're going to look at prism with square bases, prism with rectangular bases, triangular bases, and then a cylinder. And basically I'm just going to show you the different heights associated with the prism with square bases, etc. So I'll pick that one, check 0.5, you can see that I can rotate it here, and basically now I can fill in this area. Okay, the area of the square, it gives it my dimensions down here. It's a 4 by 4 square with a height of 2, so my square, the area of the base is 4 squared, which turns out to be 16. I can check that if I want to. So now that I know my volume is base times height, so it's 16 for the big B, the area of the base, which is a square, times the height of 0.5 or a half. So obviously then that is 8. So that was that first one there. Again, if you need to, you can pause it. You can pretty So now I have a height of 2 now. Basically that doesn't change my base of being a 4 squared, a 16, but it does change my height obviously. So I have a 16 of my big B, height of 2, so my volume is 32. And I can check my answers. I need to hit reset. So now I can do volume, or height of 4, height of 7, and figure out the volume with that. With rectangular bases, I'm going to pick the rectangle. I'll go a height of 2 this time. Again, I got to remember my area, my base is a 4 times 6. My length is 6, I'll say 4. So the area of the base is 24, the big B, basically the bottom. So 24 times 2. Basically it's saying how many times does this bottom fit up through itself. So it fits up through 2 times, so that's an area of 48. And I can check to see that is correct. And I can continue on with the rectangular bases, changing the height. You can figure that out. Triangular bases, same thing. Basically choose a triangle, height of whatever, 4 in this case. So there's my triangle. So my base of my triangle, they gave me a 3, 4, 5 triangle. So 3, 4, that's 12. Half of 12 is 6. So the area of the base is 6. So now I got to multiply by the height. And the height, according to what I chose, was 4. So I said volume of the base is 6. Height is 4. So we have a 24 as our base. Excuse me, as our volume. And lastly, again, you'd have to fill out the rest of those with different heights, and then the cylinder. Again, basically the only difference with a cylinder is now the base is a circle, so now we're going to use this little key down here. So our radius is 2 for our cylinder, so pi r squared, so our radius is 2, so that's 4 pi for our base. We can check that if we like to. So our base is 4 pi, our height is given as 7, or selected as 7, so that's volume of 28 pi, which is 28 times 3, so it's like 80 around there somewhere. So approximately whatever that equals, we can get a calculator out, but that's what they're asking for there. So you can finish that table then. And next up is just kind of extensions for your understandings from this table. Upon your understanding of that, then you can do 10 through 13. Okay, the next one is just composite figures. Basically, we're just going to switch over to composite, and basically I can just select a whole bunch of different figures and then give it a height, and that'll give it dimensions. So you can see there's the rectangle, the square, and the triangle. And again, using the dimension key down here, and according to the selected height, I can now calculate, okay, what's my length times width of that rectangle, what's the side squared for that square, and what's the area of the triangle. Although all those added together is the area, the base, and then we have to multiply that by the height. Again, I could continue to pick different figures, even some like that. And the one that's kind of, oh, this is the next one, but basically we can just pick any type of figure. I will show you those to whatever figures you want to. If there's two semicircles and a triangle, again, you have a choice of 0.5, 2, 4, or 7. And then there are your dimension keys to figure out what the actual volume is to fill in your worksheet. So please do describe what you've chosen, the height, and then your calculations. You don't necessarily have to write out all your calculations for the base, but the volume is what I'm more concerned with. So there's one there. Oh, I give it 3 there. Basically, you can pick and choose whatever you'd like to choose. And just calculate it out. So you might need to draw something that might not be exactly what this program would draw. Alright, the last part of this before the extension piece is basically doing those composite figures, which I think I just showed you. Yep. Okay, so in this case, they're actually telling you what pictures to draw. In the first table, you can draw whatever ones you want to, so you can come up with whatever you like to, but these are actually asking you. So this first one here is talking about two semicircles, and what was that, a triangle? Or sorry, semicircle and two triangles. So semicircle, two triangles, and it'll give you this figure, and then you can select the height, 2, 4, or 7, or 0.5, and then basically you're just going to calculate the area of that figure. The next one is, looks like it's two semicircles and a rectangle. And that's what it gave us. And again, you put whatever height or width, or excuse me, whatever height you'd like, but that's how you would construct that one. This one's kind of tricky. It actually turned out to be 3 triangles. Took me a little bit to figure out what figure that was. Again, so you have 3 triangles with the dimensions listed below. Pick a height in your table and then calculate the volume. And then finally, it looks like a triangle, semicircle, and square possibly. Yep. And now they gave us a height of a half. I'm sorry, they gave us the heights in each one of these. So that was 4, this 0.5, this one gave us 7, and this one height gave us a 2. So again, you'd have to calculate the volume dependent upon what the base is and multiply it by the height. Hopefully that drove it home for you. And the last part of this is hopefully you know what the general formula for a volume is by now, and write in your own words what that formula means and how it's used. So this is basically for you to describe to me that you understand it. The proof part just basically is breaking it down into the different things that we just did. I'm not going to waste too much time with this. The composite figure, we have a pi r squared there, and the triangle there, the base is 2 semicircles, so that's why it's pi r squared. And then you just basically simplified everything, and basically they all simplify to the volume equals base times height, and there's some conclusion. B represents the area of the base, and H represents the height. Then the formula known as volume equals big B times H. Alright, hopefully that does it for you. Let me know if not.